What could be hidden in the arid hills of southeastern Turkey? Here lies Gobekli Tepe, a hill long considered sacred by the local Kurds. On a clear day, the view from the top is breathtaking, allowing you to see all the way to the distant horizon, with irrigated farms filling the surrounding flatlands. But by the mid-20th century, archaeologists began to realize that Gobekli Tepe was more than just a scenic viewpoint. It was, in fact, the remains of an ancient village, abandoned millennia ago and covered by centuries of dirt. For a long time, nothing exceptional was found, except what were thought to be grave markers, and the archaeologists moved on. It wasn't until 1994, when German archaeologist Klaus Schmidt heard about the site from locals, that the true importance of Gobekli Tepe began to be revealed. Guided by local farmers, Schmidt began his own excavations, and soon realized that those large underground stones were not grave markers, but the tops of huge megaliths. Further work revealed an impressive complex, including T-shaped pillars, long arched paths, and concentric circles of imposing stone walls. But the biggest surprise was yet to come. When archaeologists managed to date the structure, they were astounded. The complex was over 10,000 years old. Gobekli Tepe, which in Turkish means potbelly hill, was discovered to be one of the oldest structures ever built by humans, constructed at the end of the last ice age and during the transition from a hunting and gathering lifestyle to a more settled one. The true purpose of the site is still unknown. It may have been a functional village or merely a sacred place for annual gatherings. Either way, Gobekli Tepe was vitally important to the people who built and used it. However, after it was abandoned for reasons as mysterious as its construction, it was lost to time, becoming just an old hill with some buried stones, ignored for thousands of years of human history. This archaeological site serves as a cornerstone for our modern understanding of the development of human civilization. Without it, our past would be even more mysterious. Built just 10,000 years ago, as we delve further into the past, the story of our origins becomes even murkier, with fossil fragments scattered around the world. We can piece together the general story of human evolution and development, but beyond that, we understand little more than the outlines. Scientists estimate that we have fossil evidence for less than 1% of all the species that have ever existed. And that's just life on Earth. We've only just begun to explore the broader cosmos with our probes and telescopes, and the vast majority of the universe remains completely unknown and unmapped. Like Gobekli Tepe, what ancient monuments of life await us in the depths of interstellar space? Are we the first generation or the last of a long line? Now imagine an ordinary day. You're walking across a perfectly white ice plain in Antarctica, and suddenly, a strange, dark boulder catches your attention. It looks like just an ordinary rock, but it's actually a Martian meteorite, fallen here millennia ago. This boulder, known as ALH 84001, contained microfossils that were initially considered evidence of life on Mars. The discovery caused a stir, with even the then President of the United States, Bill Clinton, making an official statement. But as is typical in science, subsequent studies cast doubts on the discovery, questioning whether the structures were really biological. The question remains, how can we identify alien life if it's right in front of us? Defining life is a challenge in itself, with over 200 different scientific definitions. A general classification says that life needs to store information, catalyze reactions, and self-replicate. But what really separates life from non-life is this ability to self-replicate and pass on its characteristics to the next generation. Take, for example, a famous experiment from 1952 conducted by Stanley Miller at the University of Chicago. He mixed water, methane, ammonia, and hydrogen in a flask, simulating the conditions of early Earth, and passed an electric spark through the mixture. The result? Amino acids, the building blocks of RNA and DNA, formed in the flask. This experiment showed that life can arise from simple, common conditions, a discovery that firmly planted the problem of abiogenesis in the scientific domain. But this is just a piece of the puzzle. To find life in the universe, we need to understand that, beyond the right conditions and elements, there is a fundamental necessity: stars. Stars fuse elements that make up the periodic table, essential for forming organic compounds and eventually life. The first stars appeared about 100 million years after the Big Bang, and only then did the elements necessary for life begin to form. What if, for a moment, we consider the possibility of completely alien forms of life? Life that could exist deep in the atmospheres of giant planets, or even in methane seas on distant moons like Titan. What if life didn't need water, but some other exotic solvent? These are questions that broaden our horizons and make us think outside the box. So, we return to the Fermi paradox. Where is everybody? If the universe is so vast and ancient, and life arose so quickly on Earth, why haven't we found signs of other civilizations? One answer might be that intelligent life is extremely rare, or perhaps doesn't survive long enough to communicate with us. Or maybe we're just beginning to explore and still have a lot to discover. What we know is that Gobekli Tepe and other archaeological discoveries teach us that we still have a lot to learn about our own past. And as we look to the stars, we continue to wonder about our place in the universe. Will we one day find alien equivalents of Gobekli Tepe hidden under layers of cosmic dust? Only time will tell. And speaking of impressive discoveries, have you heard about the theories that life could have originated in places even more exotic than we imagine? Some scientists speculate that forms of life could exist in worlds completely different from ours, such as the icy moons of Jupiter and Saturn. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are perfect examples. Both have oceans of liquid water hidden beneath their icy crusts. Could these oceans harbor life? Imagine organisms living in the dark depths of these alien seas, feeding on hydrothermal vents as some forms of life do here on Earth. And if we go even further? Titan, one of Saturn's moons, has lakes and rivers of liquid methane. The idea of methane-based life is fascinating, but it would be a form of life that functions completely differently from ours. What would the biology of a methane-breathing organism look like? What adaptations would be necessary to survive in such an extreme environment? Back on Earth, let's think about the Miller-Urey experiment. This experiment was revolutionary because it showed that the building blocks of life can form spontaneously from simple conditions. This suggests that if we find the same building blocks elsewhere in the universe, life might not be as rare as we think. But how did these blocks get here? An intriguing theory is that comets and asteroids could have brought the ingredients of life to Earth. These cosmic travelers, formed in the outer regions of the solar system, might have seeded our planet with the precursors of life billions of years ago. But the search for life beyond Earth isn't limited to our solar system. With the discovery of exoplanets, planets orbiting other stars, the possibility of finding habitable worlds has increased exponentially. We've already identified thousands of exoplanets, some of them located in the so-called habitable zone, where conditions might be right for liquid water and potentially life. And what about forms of life that could be completely different from anything we know? Scientists have theorized about the existence of shadow life, forms of life that coexist with us on Earth, but are based on completely different biochemistry and are therefore invisible to our current detection methods. Could there be forms of life based on silicon instead of carbon? Or organisms that use arsenic instead of phosphorus? Are we alone in the universe? The answer, whatever it may be, will have profound implications for our understanding of life, biology, and the cosmos itself. So, next time you look up at the night sky, think of Gobekli Tepe and how an archaeological discovery can change our understanding of human history. There are probably other Gobekli Tepes out there, waiting to be discovered on distant planets, in icy moons, or in methane seas. Thank you for watching and exploring these mysteries with us. Don't forget to like, Subscribe to the channel and leave your comments below. Until the next journey of discovery. Until the next journey.